Thank you. Well, thank you. It's really fun to be here. When I go to growers meetings, they usually just, are very quiet and they have their barbecue lunch and then they go home. So I'm really excited to have the interaction and people that are really interested in every facet of it. And Arkansas is a very long distance from here. And so much of my career in rice has been focused on southern rice production. So there might be a few things that cross over, I hope, but it is going to be quite a stretch, and hopefully there'll just be some things that you can glean from our experience that might be of some help to you. I wanted to put up this little picture that Naomi had mentioned about the winnowing house from South Carolina, and this is an example of one of those. And so if you're looking to thresh your rice, this would be one way to do it. So anyway, I'm going to kind of blow through. I've talked to several people about what would you like for me to talk about, and I've heard like 7 different topics. So I'm going to do a little bit of several of them and hopefully get to where we want to be. Let's see. So first of all, if you don't know anything about, who in the heck is Agricultural Research Service, we're a component of the U.S. Department of Agriculture. We're the only research organization within USDA. We have the Economic Research Service and the National Ag Statistics, and then the NEFA group, which provides grant funding to universities and also supports some extension activities. But we're the ones that really do the research for agricultural research for USDA. And so within the United States, we've got about 2,000 scientists with our agency. We're real proud we made it to $1 billion budget before they cut us a little bit and then they gave us a little bit back. So we're still at about $1 billion budget, which is very small, as you know, for anything in the U.S. government. But we're located in what's called the Southern Plains region, which encompasses Texas and Arkansas, Oklahoma, New Mexico, and I think Costa Rica, to really make sure it's southern. And so if you're not aware of where the heck is rice grown in this country, we don't have a dot yet up here in the Northeast, but we obviously need to change that. Where's the guy from NAS? Is he still here? Okay, there, all right. So you can see that, rice is grown up the Mississippi, and it used to be a lot along the Gulf Coast here, Texas and Louisiana. And then of course we have over here in California. And the gene pools are quite a bit different. The material that's in the mid-south area there is what we call tropical japonica material, a little bit more tropical, whereas the material over in California is the temperate type of material, and it tends to be mostly the medium grains, whereas in the central part of the United States there, it's the long grain material, primarily.
No longer the Carolina.
Yeah, we need one other dot, right?
Did you do your report?
I have to stay late after school.
So, it used to be there was a lot more acreage here along the Gulf Coast, and what we've seen over time is that it's essentially moving north, and now it's up into very far north, and now we're up into the Boot Hill of Missouri. And one of the drivers of that is urbanization, for one thing, along the Gulf Coast, a lot of industrial area there, hurricanes, which Glenn mentioned that we get to have down there in that area. And there's a lot more rural area as you move further away from the coast. So we're just seeing kind of a gradual movement of rice a little bit further north. And one of the biggest issues facing the rice industry's sustainability is access to water. And so this is in Arkansas, most of the irrigation there is done through underground pumping, and they have aquifers that are not being recharged. And so this is a huge issue facing the industry that up until about 2 years ago, they pretty much have had their blinders on and just hoping it was going to go away, but it's not. So this is really something we're faced with looking at as researchers, how to deal with these new stress factors that are coming into the production area of the Mid-South. So this is where I work. This is the Del Bumpers National Rice Research Center. It's called Stuttgart, Arkansas, not Stuttgart. And although it was settled by Germans. And we're very proud. This is you folks in here that do pay your taxes. This is where some of it went. No, I was told that it didn't, I don't know. I thought some of these places didn't have taxes or something. But anyway, we have a very lovely center, and we're very proud of it, and we use it to the fullest capacity, and it's all about rice. It's completely focused on rice. And so we have a number of scientists there. Our full staffing will be 12 scientists. We right now have 3 vacancies. We have a genetics group. My area of research has been in breeding. Dr. Yan here, who's in charge of the germplasm collection. So all these rice varieties you folks asked for from USDA, he's the one that has been responsible for growing them up, producing the seed, taking some notes about it and characterizing it. And then Dr. Eisenga is working with Susan McCooch and myself, and she's involved with making wide crosses. And Dr. Penson's working on molecular genetics. And then we have Dr. Chen and Bryant that are working on grain quality issues, both nutritional and cooking quality. And then we have a molecular genetics group, Dr. Felstrom and Jha. And then at this point, one physiologist, Dr. Gailey, who's working in weed physiology. So you can see within this one building, we got kind of a, hopefully a critical mass of people to kind of address the issues facing the rice industry from many different directions. And so who do we serve? Well, we serve, of course, the taxpayer, and that taxpayer can be a consumer of rice, can be a producer, can be a miller, can be a processor, but mostly the people that are the beneficiaries of the research that we do are actually other researchers. Because the research that we do is actually a little bit more basic than you folks are in there, you know, trying to figure out how do we deal with this problem today. That's more the university and extension type of folks. So we really try to do some basic research that kind of feeds into the extension and the university researchers. But at times we have opportunities where we can work, like with Glenn, directly with seedsmen and with farmers that want to have some unique opportunities that, you know, we maybe are developing some things that would fit directly with them. I've worked extensively with Uncle Ben's Mars over the years and have worked with them to develop varieties for their particular processing. And so although our research is a little bit more basic, not as basic as Dr. McCooch's work, we're really trying to influence other researchers mostly. And so just very simplistically how we're doing that, we're all focused upon utilizing the natural genetic variation that occurs within the rice gene pool. At this point, we're not doing any GMO research at our center. And so what we're trying to do is assess the genetic diversity that does exist, understand what those traits are that would be beneficial to our growers, and then we're trying to develop genetic markers that are linked to those traits. And then ultimately we want to use those markers and that trait information through a process called marker-assisted selection to develop new rice varieties or new breeding materials for other breeders, and ultimately to develop rice cultivars that can be commercialized. So the USDA is part of a large germplasm, a genetic resource center, and we are responsible for curation of the rice genetics material, of course. We have about 18,000 rice varieties in this collection, and because this is a picture of the grow out of one of Dr. Yan's fields in Stuttgart, and so he's responsible for growing out this material, regenerating it, making evaluations on it, and then providing that seed. That seed then goes to Aberdeen, Idaho, where it goes into storage. And so when you go online and you go to the GRIN network and order some seed, it comes from Idaho, but it actually came from Dr. Yan's lab in Stuttgart to begin with. And then there's a backup storage, long-term storage of all of those seed accessions in Fort Collins, Colorado. So if we were to have some sort of disaster, we would not lose these valuable genetic resources. And those genetic resources come from all over the world. You can see, of course, rice is not indigenous to the United States, and we've gotten a lot of our collection from China and Southeast Asia, but we've really been fortunate to be able to really cover many different areas across the world to access this genetic diversity. And as you know, Naomi's presentation showed the many different growing environments that rice can be grown in. And you know, we've tried to have access to that material so we can explore the genes that are in those materials and be able to utilize them. And so this is just a couple examples of how that diverse genetic collection, some examples of how they've been used to actually develop some new rice varieties. And so this is an example of, there was a variety called Tep, which came out of Vietnam and was brought into this country in 1978. And then it was used in making some crosses, actually there in Arkansas by the University of Arkansas. And they were able to introduce a very powerful disease resistance gene from this source that came from Vietnam. And that disease resistance gene then ultimately ended up in a whole set of other varieties that are down here. And all these varieties have this gene, and they have very broad spectrum resistance to this disease called blast. And it's called rice blast. It's found just about wherever rice is grown in the world. And as you can see, when it hits the panicle, it actually blanks out the entire panicle. It's a very devastating disease. And so here's another example of where we've used some materials from the collection. And there was a variety that was grown in Mexico called Jojutla. And Uncle Ben's was down in Mexico, and they said, boy, we had some of the best rice down there. We sure would like to grow that up here in the United States. Well, that variety wasn't at all conducive for being grown in the southern U.S., and so a series of crosses were made by Dr. Bollock at Texas, and he came up with the first rice variety called Nurex, which had a different cooking quality to it. So when it was parboiled, the grains were actually nice and individual versus kind of mushy. And also when they went through this parboiling process, they didn't lose as much starch into the water, so it was less starch solids loss. And just the appearance of the grain was much nicer. And so that gene that came from that variety out of Mexico ended up in all these other varieties down here at the bottom. And it's actually the gene that you find in Campbell's rice soup and some of these other different products you see out here. And so we're very fortunate to be able to have this collection, and we're trying to really mine it for these very valuable genes. So I mentioned the molecular markers, and I guess just a very simplistic way of what we're trying to do is identify genetic markers that can be linked with traits. And so one way I kind of present this is that if you think of the chromosome in the rice plant as essentially a series of boxcars in a train, and we're trying to put flags on certain boxcars. Some boxcars we want, and some we want to get rid of. And so just like in a train station, you kind of go in, you want to get rid of some and kind of line some others up. And so that's what we want to do in breeding, is to put markers with certain genes that we are interested in keeping, and then use those markers to realign those into a new cultivar that would be improved.
You have music along with that?
I don't. See, I think of boxcars, freight train, I don't know.
She's from the Delta.
Right, you're right, the blues. We sing the blues. So the other very interesting thing that these genetic markers have enabled us to do is that we're able to make even wider and wider crosses. And so much of that 18,000 different cultivars that are in our collection really haven't been utilized by the breeding community. And the reason is, although they have good traits in there, they also have a lot of things we don't want. And so when the breeders have tried to make just these simple crosses and make selections, they just feel like they lost more ground than they gained. And so a lot of times breeders have just kind of not utilized that material. So now that we have these genetic markers, we're able to, like I say, go in and essentially surgically remove the trait you want because you have a marker linked to it and move it into your new cultivar of choice. Well, not only are we able to use this genetic diversity of different rice cultivars, we're now at a point where we can actually start utilizing other species of rice. And so just like the weeds in any of our gardens, they're very vigorous. Why do they always grow the best versus the thing that you want to grow, right? And they have, you know, good disease resistance, good insect resistance. And so these other species of rice also have some of those very beneficial traits. And these genetic markers are enabling us to capture those traits from these very, you can see how fun it would be to try to make a cross between something like this and one of those cultivated rice species. And the sort of progeny you might get out of it would not be very desirable. So having the markers will actually help us utilize those materials more effectively. And so this is actually just a little picture of some of the work I'm doing with Susan that we've worked on for a number of years, and we used a rice variety. It's called from an Hals background. It's a weedy species. There's nothing that a breeder would like about it. But we crossed it to a variety called Jefferson, and using these genetic markers, we've been able to move certain chromosomal regions into the cultivar of Jefferson. And we actually have now found that some of these little pieces of chromosome, when they're moved in the cultivar Jefferson, have resulted in a 20% yield increase. And so this is just proving that something that's really kind of ugly and only its mother would love it can actually have a lot of impact in terms of yield potential too. All right, so I'm going to switch to some organic rice research. And unlike many of you folks here, the reason why I got interested in organic rice research was I was seeing our conventional farmers starting to, just starting to die out because they couldn't be competitive. And so I was looking for ways to try to find new markets for our farmers that would, essentially assure them of a good price and that they could be economically sustainable. And so probably about 10 years ago, I started working a little bit in organic rice research there at that point I was in Beaumont, Texas. And so what we've seen is there's a steady demand for organic rice. And even though we see a lot of our other plain old milled white rice, sometimes it's hard for us to find markets for that. There's just a constant demand for organic rice, whether that be brown or milled rice or even rice flour. And we're actually even seeing that rice is being used to make like rice milk and some of these various sorts of drinks and all kinds of unique products. And so probably within the United States, at a maximum, we're looking at about 50,000 acres. Half of that's going to be in California. In Texas, we've had up to about 40% of that acreage at times has been in organic rice. And one of the reasons why we're seeing an increase in Texas in organic rice is because we're actually seeing a decrease in conventional rice farming. And so rice farming in Arkansas and other places is actually being more productive. They're having higher yields, less problems with hurricanes and that sort of thing. So if you can imagine on the Texas Gulf Coast there's a lot of fallow land that's rotated with cattle. And so what that means is, on the good side, is there's land that's been out of rice production for a number of years. You can quickly go back into organic or claim it as organic, one thing. The other thing, you're in rotation with cattle. And so you don't have a lot of other rice around you that has a lot of pesticides being applied to it. And so it's a lot of protection for the growers for organic rice. So we're actually seeing what used to be conventional farmers are now converting to organic. And so very different from what you folks, you're organic to begin with. And so what we've been trying to do is how can we develop information and technology that will help them make that sort of conversion. The other thing is because of the interest in organic rice, that rice is always grown under contract. And so the farmer goes in, knows he has a price that he's going to get for his rice, and versus just trying to be out there on the open market. So that's another risk reduction for them. They're also saying when we've had times when you have these spikes in fuel prices, just the cost of the fertilizers and the cost of the various sorts of other pesticides that they've used, they can get away with a lot more and actually have a much higher return per acre. So that's where we're seeing a lot of interest, is the money that's associated with it. So what we're trying to do in short term was to develop just basic knowledge about what are the production practices that will help rice farmers in the Gulf Coast area there. There's all sorts of products, of course, fertility amendments that are being sold to farmers, and which ones of those are snake oil and which of those actually have value to them. Weeds, of course, are the biggest issue in terms of any any organic production issue. And we also have found that we're seeing diseases in organic rice that we don't typically see in conventional farming, and so how to deal with those. Long-term goals that I'd actually like to have a breeding program to develop rice varieties that are particularly suited for organic production. There's some materials in our collection that are called allelopathic. They have a natural ability to prevent weeds from growing around the rice plants, and these have been documented to have a definite effect in terms of barnyard grass and duck salad. And we want to, if we could eventually identify genetic markers for that trait and then put that into varieties that our growers are interested in producing. In our area, I think for someone to be an organic farmer, I don't need to tell you guys this, that you're not just going to be farming rice, it's going to be in a system. And so for large tracts of rice land down in the Gulf Coast, what would be the other crops that they could move into that organic system to help sustain the production practices and sustain the quality of the soil for organic? And one of the big probably challenges in that situation is many of our farmers are actually tenant farmers, and so they don't own the land. And so when in my mind, I think, and what they're doing is they're essentially going wherever they can find fallow land and plant rice there because it doesn't have weeds or other problems with it. But for the long term, I think you're going to actually have to invest in the land, as you folks are all doing, to actually build up the soil. And so I think this is going to be one of the challenges for organic rice production in our areas, to have farmers that actually have control over the land and are willing to make those sort of investments. So I guess the bottom line is what I've seen in my work is that you just can't get enough fertilizer available to the rice plant, and so we started looking at with organic amendments. And so what we started looking at were what would be some cover crops that might help build that soil. So I'll show you a little bit of work on that. So we'll be looking at fertilizer amendments, what different sorts of cultivars would be the most productive, and we're looking at varieties that are not only what we call conventional, medium grain, long grain, but also some of these specialty varieties that are aromatics, or waxy rices or colored rices, looking at some green manure crops and various seeding methods and disease management. So just real quickly, I had done some work quite a few years ago where I was looking at organic production methods versus conventional, using half of the nitrogen that a farmer usually would and 100% of what the farmer would usually use. So what we're just seeing is that under organic management, the plants are essentially nitrogen stressed. They don't have as much nitrogen as you would expect in a conventional system where they're just dumping fertilizer on. And so what that results in is the plants mature a little bit earlier. They tend to be shorter. And on the good side is you actually see less lodging. The plants don't fall over because they're not so top heavy. We also see that you can have a little bit lower milling quality. And so the good news is that if you're looking at maybe a brown rice market, you're not so much concerned about the milling yield. And so maybe that wouldn't be as a big a factor as it would be in regular conventional rice. So out of this, we've learned that we need to have, you're going to have weaker stands, and that may be due that we're actually having more seedling disease that we're not even aware of. And so we're recommending higher seeding rates. It's going to be an earlier harvest, and so if that's the case, you can probably plant what would have been otherwise maybe a little bit later maturing rice varieties. The plants are going to be shorter and less susceptible to lodging, so you have the flexibility of using materials that would have otherwise been kind of tall. And I mentioned on the lower milling yield already. And also we're seeing these diseases of blast and sheath blight, which are very common in conventional production, we don't really see under organic management. So here's some of the different products that we've looked at. Agri-Recycle, Maximum Compost, and Nature Safe. And so this is looking at one variety, Presidio, which is one that's being used quite a bit in Texas for the organic market. And we just looked at different rates of application of those products. And you can see the product called Nature Safe. You know, essentially you're seeing a linear progression of, and the more nitrogen or the more of the product you put on, the higher the yield it goes up. Whereas this product here, the Maximum Compost, regardless how much fertilizer you put on it, it didn't really respond. And so the one on the far right there, I mean, that just says to me, again, back to this nitrogen stress issue. We want to do things to actually make more fertilizer available to the plant to maximize yield.
Is that right one chemical?
Is that what?
Is the Nature Safe chemical or not?
These are all organic products.
It's all organic.
Right. Mm-hmm. And then here's another one, another set of 3. And so the Rizogen is another one that, you know, just seems to continue. The rice continues to respond to increasing applications of it, as do these others too. So as we went into the next kind of level of our study, we just focused at this next step, looking at Rizogen and the Nature Safe. So here's looking at different rice varieties, and not that these are things that are adapted to the South, so you're not going to be that interested in them, but just to show you that under the maximum level of Nature Safe, and this is over 3 years of work at Beaumont, just the huge difference that we see in different rice varieties. So you've got a few rice varieties out here out back, and you just need to continue to look for the right one, because hopefully you'll get, you know, those that are very responsive. And what we see here is these varieties that have the highest yield potential, at least in our southern area. Those are things that come from southern China. We call them indica rice varieties. And they're just very responsive to the nitrogen inputs. And these 2 rice varieties here, these are the ones that had the allelopathy, the weed competition aspect, so they did pretty well. So we have a number of Presidio here. This is one that is being grown right now quite a bit. And so you can see there's potential for identifying other rice varieties that have higher yield potential. So I also mentioned that we're seeing diseases that we don't usually see in our conventional fields, and here's brown spot. And so this is just one that, you know, we typically say these are minor diseases, but we see them quite frequently in the organic production. And so you see these round, dark blotches forming on the leaves, also can form on the panicle. And it actually is going to just kind of reduce the yield a little bit, will be the main effect. Here's another one, narrow brown leaf spot. So it's the same sort of thing, except the lesions are kind of little brown boxes that you'll see.
Fungal disease?
Yes, fungal disease. And so this one, not only will it reduce yield a little bit, it'll also cause the plant to dry down faster. And what that does is it causes the grain to dry down faster, and it reduces the milling quality. So these are things that we have to look for. So what we've seen, we did those nitrogen response tests I was showing you before. And so this just shows that with increasing nitrogen applied using organic fertilizers, that the level of the narrow brown leaf spot disease decreases. And so this is just showing that, you know, if you're under a really nitrogen stress conditions here, you're going to have high levels of that. And so this just reinforces what can we do to improve the soil nutrition quality in an organic system. So this is where we've moved into looking at various different sorts of cover and green manure crops. Again, this is very far south from you folks. So we've looked at some things for winter cover crops. We've also looked at some, this is actually a Sudan grass being grown in the summer as a plow down. And this was one that Glenn suggested that I work with, Elbon cereal rye. And so this is an example of, in our fields, it's a heavy clay soil, and drainage is critical because all these sorts of green manure crops you want, they can't tolerate much standing water. And so we tried this for a couple of years just in our fields that we had, and you can see where we had some wet spots and such, we just had horrible stands. Where it was dry, we got pretty good stands. And actually, in those areas of good stands with the cereal rye, it looked like we didn't have much weed pressure. So we went back in, we laser leveled our field, smoothed it on out so we didn't have those wet spots. This is an example of some of the green manure crops we tried in the summer, and they were, of course, in our area, sorghum Sudan grass, very productive. And then I'm going to touch on a couple of our winter cover crops. This is a ryegrass that we planted, and we got, so this would have been planted like in about October and then grown through the winter and then plowed down in the spring. So we got really pretty good stands and good cover. The thing about these cover crops is, in addition to the fertility that they're going to bring to it, we're seeing good control of our weeds. One of the most spectacular has been this white clover, and so this is just a fallow field versus one where we'd seeded the clover, and you can see we got really good growth. It's slow to take off in the winter, but then you know, it comes on kind of late spring. So this is one of the problems, you know, can you get it in there long enough to get the nutrient value before you have to plow it down? And it's pretty tight turnaround time if you're just trying to do it from the winter and then the following summer have rice. This is showing that where we let that clover continue to grow another season, that we really were getting pretty good weed control, and so I was really pleased with this. And so, particularly in our area where we have cattle, you know, we're thinking that if we had growers that wanted to run their cattle on the clover, and then so they'd plant it in the fall, graze their cattle on it in the next year, let it go through the next winter, and then the following spring would be a plow down and go into it with rice. So this is some of the work we've done where we've looked at the effect of these green manure crops compared to conventional management. And the first time I started, you know, looking at some of these numbers, I didn't really want to present them because I didn't believe them. But what we're seeing is that, you know, that we're actually getting higher yields starting to develop. At first, you know, in 2009, the conventional, the organic were pretty similar the next year. And then the next year, we saw quite a jump. And this has averaged over about 20 different rice varieties.
Is this still using the same prescription of the nitrogen, like using that fertilizer on these fields as well? Yes,
this was using the Nature Safe following the clover plow down. So again, this is being done on a station that's been in rice production for about 100 years. And so we're working in an area that's been managed as organic for probably about 5 years. So I'm hopeful that we're actually starting to see some effects from our organic management and our plowing down. Now, of course, in organic, you know, you hear about minimum till or no till and those sort of things. And so we tried that, trying to go back right into our clover field with a minimum till and just drill seeding in the rice. And we just not discovered, but observed a new problem, or another problem. It's called straight head. And so this is a problem that in the past has been associated with arsenic compounds, pesticides that have been used. And it's a physiological disorder, and what happens is the panicle develops, but the seeds don't fill. And so the panicle just stays straight. And what we found that when we tried to use no-till and just drill right into the clover, we got very high levels of this. And so this is an example where organic management in rice is going to be very special, you know, compared to some other crops. And you get problems that you wouldn't have expected in other instances. And so this is just an example. We have rice varieties that are resistant, sidebonnet, and cocodrie, which is a widely grown cultivar in the South, is very susceptible. And so you can see those panicles are just standing straight with, you know, no grain forming on them. And so this is just looking those same set of rice varieties, but they're drill seeded directly in no-till. And so at the very far right there, you see the variety coquetry. And the reason why the yield is so low is because of that straight head. And this just, again, shows that there's a wide diversity of varieties that have resistance to this disease. And so, you know, if you're going to have that kind of management, you got to match it with the right rice variety. And just to show you some of the work, how we plant these, this is, of course, all experimental plot work. It's not on farmers' fields. So this is a heavy clay soil, and it's cultivated. Here this is our little experimental planter. And so that was all drill seeded, and this is where it's come up. And you can see the different plots. Each one of those plots would be different rice varieties. And you can't really see it here in this picture too much. But one of these you could see, I think it's this one actually, that there's a lot of weeds. This was actually a field that was fallow, had been fallow. And so we just drill seeded into it. And this is the one that was following clover. And what you should be able to see is that there would be less weed pressure in this field than the previous one. And then later on in the season, this is how that fallow field looked. We're just getting inundated by weeds. And so again, just showing that those cover crops helped us in some of the weed management also. So this is those fields this year. We've had really heavy duck salad infestation. And that's usually not a problem, but when you have a lot of open water, particularly where you have experimental plots like this, that can be a problem. It doesn't really affect yield so much. Certainly doesn't make it look very pretty.
Anna,
yeah.
that difference you saw with cover crop with regard to weeds, was that more of an allelopathic effect, do you think, or something?
I guess I'm thinking it's just weed suppression, suppression of the weed seed bed, but I don't really know.
I have another question about that. So when you're looking at the weeds that came up after a system had been flooded, how many months later was it after the flooding?
It's how many days. Right.
I was thinking in the South, you probably have a longer season for weeds to grow. So.
Oh, yeah.
We do, and that's, we're talking about planting Pipped seed and, everything you can do to get one notch ahead of the weed growth because it is so warm. The weeds are growing also. And they respond to nitrogen just like the rice does. So the more nitrogen you get out there, the more they like to grow too.
Yeah, we don't need to skin shots, so ground.
Yeah.
So this is actually one of our yield plots, and it's just got a lot of barnyard grass all the way through it. So this is from South Carolina. We have a little SARE grant that we're working on in conjunction with our folks in Clemson. And so we got notified very late that we were going to do this research in South Carolina. And so I went there and took a look at the fields this spring, and they were about, this tall in grass. And I'm like, you want us to plant rice in there? And I thought, there's no way that, we're going to be able to be successful in planting rice in there. But Hal went in there and he cultivated it and he made the beds like you folks were telling about it. And so then what we wanted to do was to use water seeding method. And so what he set up was these little barriers, and each one of those little troughs, so to speak, is going to hold different rice varieties. And so I was not hopeful at all that this was going to work, but anyway, he did a good job.
By the way, Hal does that stuff with a bulldozer. He's good. His berms don't blow. He can do it for 2-acre fields and they'll hold.
So this is where he's, after he's flooded it up, and so what we did, we sent him, I forget how many, 8 or 9 rice varieties. He took that rice and it's in a cloth bag. He soaked it for 24 hours and he let it drain, I think, for 24 hours. And so it's what they call pipped. You just get a little bit of a root shoot coming out. And then he goes and dribbles that rice into these flooded beds. And we do the same thing, we've done the same thing in Texas, and this is where we've gotten our best stands and our best results is in water seeding. The problem is it's very labor intensive, and my guys here, they call this feeding the chickens. So they're just dribbling the sprouted seed in each one of those forms, and each one of those forms again are different rice varieties. And so this is back at Hals Place, and so you can see the rice is starting to come up through the water. And then this is a few weeks ago. It got excellent stands, essentially no weed pressure, very little weed pressure. So they did an excellent job for the first time out of the chute in South Carolina. And so this is just an example of one of our organic fields. This was drill seeded, but they're at Texas. Also, I'll just stop very briefly here, just touch on, again, looking at different rice varieties. We've also looked at a couple, these two rice varieties here were red bran. This is usually the stuff that Glenn wants to get out of his field. But one of my colleagues, Ming Chen, our cereal chemist, she's looked at the antioxidant capacity of some of these pigmented rice varieties. And so just like, you know, the blueberries and the red wine that we're supposed to be eating and drinking sort of stuff, she's looked at the antioxidant activity of these red bran rice, and it's very high levels compared to these others here are just typical brown rices. And so I just mentioned this to you that I think there's going to be, you know, a marketing opportunity for these colored rices, not only because of their appearance and their taste and that sort of thing, but they're also going to have, you can, you know, consider a health beneficial effect associated with some of these.
What I'm noticing on that one that the conventionals are running higher levels of antioxidants. Is that correct?
This one here, this is what we would call, it's not significantly different. There is a little bit of a trend. And the other one, yes, it was. I mean, and that may be just, again, back to the productivity, you know, just the growth of the plant and that sort of thing. Don't really know. Maybe, you know, back to the nitrogen availability. And then we've also looked, she also looked at these for vitamin E, which is, of course, this is in the brown rice that we'd be looking at. And in this case, the brown rice is red. And just that here, this is actually, I meant to say, this is the Jefferson Rufipogon line that came out of the cross that I've worked on with Susan McCooch with a wild species. And so that's a red rice line that has higher vitamin E content. So something that might be interesting to look at. So real quickly to summarize what we see in organic production in general: decreased milling quality, increased whiteness when it's milled, and that's partly because you see a little bit more chalk in the rice. We've actually done some mineral analysis and saw no difference in mineral accumulation between organic versus conventional. A little decreased protein, and again, this kind of gets back to the nitrogen stress. We've seen no negative impact upon cooking or sensory properties. Even on the aromatic rices, there's no big difference on those. And in some cases, on the colored bran rice varieties, we actually have seen some health beneficial compounds. So organic management in our hands has been nutrient stress. We need to be looking at green manure crops. And these plow downs, if we're going to use them, we need to do that early enough so that the organic matter has enough time to break down so we don't get in a situation where we're going to see some straight head. Leveling the fields we think is really critical for uniform water control. And also if you're going to be having those green manure crops, because some of them just aren't going to be tolerant to water ponding. And in our area, we try to delay as long as we can in planting just so that the rice has a better competitive advantage over the weeds that are coming through. We recommend water seeding. We've gotten our best situation or stands with that, and also almost a doubling of the seeding rate as we would otherwise in conventional situations. So with that, I'll quick. I think I had. This is Carolina Gold.
It's lodging.
So we went from 1910 to 2010, right?
Yep. Took a little hike.
So, any questions or anything? Yes, sir.
You talk about the late planting, and do you mean you start to plant it and it's 4 leaves or 5 leaves, or?
So we're not as industrious as you folks. We don't do the transplanting, and so what I'm saying, later planting in the season when it's warmer. And so whether that's being done through water seeding where the seed is already sprouted, or whether it's just due through direct drilling like you would wheat crop. Yes, ma'am.
What does your organization do to protect organic farmers from Monsanto?
From what?
Monsanto, the GMO king.
Nice.
rice? How can we get GMO out, keep that out of the rice?
Well, right now, I don't know how long it's going to exist, but right now the rice industry wants to keep GMO out of the rice. And that goes back to, at this point, Europe is not accepting any rice that would be GMO. And they don't want to lose the European market. But as other countries like China or whatever country might start developing GMO rice, there's going to be more and more pressure for that to happen within the United States.
And like your organization is the USDA?
Yes.
So is there any feeling about like we need to protect the organic farmers, or you don't really talk about that?
Well, I will say this, over the last several years, there's been pressure from the organic industry to USDA in general. And they say, why aren't you doing organic research? If we're, whatever the crop may be, if we're 10% of the acreage, why aren't we getting 10% of the funds, is essentially what they've said. And so we're starting to see, kind of some, it used to be, organic was not, that was for other people. But we were seeing more and more of that starting to take place within our agency. There was a time there where I was actually told, I don't want to ever hear the word organic, because we're not interested. And if I say, well, there's a few farmers out there, well, you go talk to them, but don't talk to me about it. And so, that's transitioned over time.
And that's getting better. So you mean that it's lost the past and now it's organic is going to be infiltrating in the USDA?
Like I say, in Texas, the economics have caused the conventional farmers to change because they're not competing. And so they're looking for other ways to be rice farmers still. And so this has been an opportunity. If I say organic in the state of Arkansas, they're kind of like, what are you talking about? And so it's still, there's really not much opportunity for organic rice in Arkansas because there's just so much acreage. Half the country's rice is produced in Arkansas, and it's all conventional.
If you say organic in Erie, they say, what?
Yes, ma'am.
Well, just following up on that, it seems like your data there that, your yields have increased after 3 years of organic management would be really important to get out to people. And I'm wondering if you're going to do further research to figure out, why that is in terms of changes in the soil and microbiology, for example, because that's a huge part of what makes organic production
exactly
work.
Yeah, and I'm fortunate that we were able to get a small 3-year grant from SARE to continue the research at Beaumont, even though I'm now in Arkansas. And I am working with a pathologist and a soils nutrient person. And we're hoping to, it's still very competitive and we have to really try to gather money as we can. But we do have people that are interested to work together as a team because it is very complex and we don't know the mechanisms of this is happening. Right?
One of the things you can do, and I don't know whether this is allowable up here, but where I am, you can go to your local research facility or ARS or whatever and say, what do you want? They've been really kind to me over the years, and they are mandated to do an offset organic acreage in all the ARSs. What they do with them is their business, but when you make it worth their while and they know that you're actually going to do something and not just show up and leave again, they actually have been very supportive. So, like in this particular instance, I was Hal's tech in that picture. I hammered all the stakes. So it suits my intellect.
I just want to put one picture up here. Some of you talked about, this is a water management scheme. We call it row rice, and it's being used in Arkansas to save water. And where they're using it is on land which has a pretty dramatic slope in it. And so if you were to put rice into that land, you'd have to put a lot of cross levees, right, to be able to manage the water. And so what they're doing, of course, it's not organic, but they're essentially using like the vegetable type of system that you were talking before. And so you have a bed, so we've got, four rows here that are probably 7-inch spacing, so 28 inches there, and then that's a bed there, and then there's a furrow on either side. And so in this sloped land, they run water down through those furrows, and it permeates through the bed. and then they catch the water at the other end and they manage to run it back around so they don't lose their water. But of course they're using herbicides in this type of situation for the weed control, but this gets back to the water issue I was mentioning, which is really very critical for conventional rice production. They're going to have to come up with ways to better manage their water resources, and this is one of the ones that they're looking at. Yes, sir.
What would you recommend for a cover crop in the winter in the Northeast? Because we harvest by the end of September and there's not really much time to get anything going anymore.
Yeah, and I don't.
In a wet paddy.
Right. Yeah, that's one of the problems, is finding something that can tolerate those heavy, wet soils. And I'm not that familiar with, you know, sorts of situations up here. And it might be the kind of thing that you really have to be in a longer-term rotation where you can actually establish it in the summer, let it, you know, go through a year. Yeah.
So that we maybe do 2 years of rice production and then 2 years of cover crop, a year and a half of cover cropping, and then.
Yeah, or something like that. Yeah.
But I'm wondering about that co-cropping thing that this guy talked about. Where he's growing something that'll fix nitrogen right in there with the rice at the same time.
Perhaps, of course, they don't. You know, well, a lot of crops don't do well when it's wet, so that's the other problem. But, right.
Well, of course, at the beginning of September you don't have water in the paddy anymore, but then you can't seed because you still have to go in a few weeks later to harvest everything, so you will kind of trample on the young seeds.
I think you could actually maybe with the relay cropping, seed something in while the grain matures, and then when you harvest you may make a track for you should be disturbing all the rest.
Tip-top.
Tip-top drainage.
Okay.
So thank you, Anna.
Thank you very much.